Okay, Wildcats, today we're going to 2. All systems go. Systems of quadratic equations. The teacher works 1 and the student works 2, 3, and 4. Alright, so to take a look at number 1, I can solve each system of equations. So to do that, we're going to go to Desmos. So I'm going to graph y equals 2x minus 5 and y equals x minus 1. And your solution is 4, 3. Okay, go ahead and finish up 1 and then complete 2, 3, and 4. All right, let's take a look at the next page. All right, getting started. Block that kick. A punter kicks a football. The height of the football in meters is modeled by the function h of t equals negative 4.9 t squared plus 20t plus 0.75. Where t represents time in seconds, a blocker can only attempt to knock down the football as it travels upward from the punter's foot. The height in meters of the approaching blocker's hand is modeled by the function h of t equals negative 0.6t plus 3. Where t represents at the same time, can the blocker knock down the football? 1. Describe the shape of the functions that model the football's height over time and the height of the blocker's hand over time. Okay, so the graph of the height of the football over time is the parabola that opens downward here and is represented by this equation. Okay. And the graph of the blocker's hand over time is the decreasing line here, and it's represented by this equation. All right. Go ahead and finish up that. Mark out question 2. Let's take a look at the next page. I can model and solve systems with linear and quadratic equations. Activity 2.1, modeling a system with a linear and quadratic equation. A system of equations can involve nonlinear equations such as quadratic equations. The scenario described in the previous activity models the relationship between a quadratic and a linear equation. 1. Use Desmos to sketch the graph of the system described in the previous activity. So let's go ahead and write down those two equations. So h of t equals negative 4.9 t squared plus 20t plus 0.75, and h of t equals negative 0.6 t plus 3. All right. Now, before we graph, we need to go to Desmos, and let's remove the previous problem, and we need to adjust the window. Okay. So our window is between 0 and 5 and 0 and 30. So 0 and 5 and 0 and 30. And we can zoom out just a hair to see the axis. And let's go ahead and graph. So h of t. Now, we have to use x instead of t. So h of x equals negative 4.9 x squared plus 20x plus 0.75. Okay. And let's pick 3 points so we can form the U. So this point, and this point. Now we're going to have to round a little bit. So let's say that's close enough to be 1 when we graph it. So that point is right here. It's between 0 and 3. And then here, let's just round that to 221. So 221, and then let's just round that to 40. Okay. And then let's graph this. So h of x equals negative 0.6 x plus 3. And the only two points we want are the points of intersection. So this point and this point. And let's round that to 1 decimal place. So 0.1 comma 3, or actually 2.9, and 4.1 comma 0.5. Okay, so let's go ahead and graph these points. So 0.1, 2.9, so it's about right here, and 4.1 and a half is right here. Grab the rock. Okay, there you go. All right, go ahead and complete the graph on number 1. Okay, number 2. How many solutions does the system have? Round to 1 decimal place. The system has 2 solutions, which are the points (0.1, 2.9) and 4.1, 0.5. Okay, number 3. Does every solution make sense in the context of the problem situation? Explain your reasoning. No, only the solution represented by the point of intersection as the parabola increase makes sense. The blocker must block the football as it travels upward. 4. Use the graph to approximate at what point the blocker can block the football. Interpret your solution in the context of the problem. The blocker can knock down the football at 0.1 seconds after it's been kicked at a height of 2.9 meters. All right, go ahead and finish it up. All right, let's take a look at the next page. Activity 2.2. Solving a system with a linear and quadratic equation. We don't need to worry about this statement. Let's take a look at number 1. Consider the system of linear equations and quadratic equations shown. Please mark out A, B, C, and let's look at D. Let's identify the solutions to the system equations with Desmos. All right, so let's go ahead and do that. So I'm going to go to Desmos. Let's remove the previous problems. Always press the home screen when you're starting a new graph. So y equals 2x plus 7, and y equals x squared plus 4. We'll zoom out just a hair and drag down, and there you go. So the system has 2 solutions, -1, 5 and 3, 13. Right, let's take a look at the next page. All right, go ahead and mark out E and F, and then read and write down the notes for number 2. So number 2, think about the graphs of linear equations and a quadratic equation. Describe the different ways in which the two graphs can intersect and provide a sketch of each graph. So if it has two solutions, the graph looks like this, and it has two intersecting points. If it's one solution, the graphs look like this, and it has one intersecting point. If it's no solution, the graphs look like this, and it has no intersection point. Okay, go ahead and write that down. Well, let's take a look at the next page. All right, the student works 3A and 3B. Let's take a look at the next page. The student works 1, 2, and 3. Go ahead and mark out the right. The student works 1A and 1B. And then go ahead and mark out number 2. And then the student works 3A and 3B. All right, go ahead and start working on your assignment and have a wonderful Wildcat day.